For today's discussion, I will be discussing an interesting topic, at the same time a controversial in the field of engineering and science, the lightning protection system, a protection against the lightning strike. In this discussion, I will focus only on the early streamer emission, or known as the ESE. So for its design, installation, current testing method, and its commissioning. Before going through the discussion, let's define first what is lightning protection system. So lightning protection system is designed and built to protect from the potential lightning strike that may hit the facility. And I also hear a definitions of the not a definition but a descriptions of what is early streamer emission, because some other are confused with lightning protection system and the early streamer emission. So when we say early streamer emission, it is a type or a method of a lightning protection system. So it is a lightning protection system type that use an electrical triggering device to increase efficiency of lightning protection. So as compared to the conventional type. I have here some of air terminal and ESE type which I use and I found on the site. So actually, I have here from the left side the first one, an air terminal with a protection radius of 106 meter at a level 4 protection. So the second image in the middle, a air terminal with a protection radius of 95 meter at the same level, and the next one is the air terminal with a protection radius of 113 meter at level 4 protection. So just to give you a what it looks like of ESE. Common application of the lightning protection system using the early streamer emission type. So I have here a commercial building which include the stores and condominiums and malls, institutional facilities, open field or agri-farms and agri-farm, industrial facilities, and the power plant facility. So maybe you were wonder why residential house is not included on my common applications of LPS. So just to remind you all that we are talking about the ESE type LPS. So the main reason I did not include here, it's because the cost-effective consideration. So common air terminal, this one, air terminal alone costs 30,000 to 100,000 in Philippine pesos alone, compared to using a conventional type for residential house, which can provide also a protection for lightning strike, so which just a less cost with the minimum budget alone can provide the complete system of LPS. Okay, let's go now on. Also, you will be answered why LPS for residential are not using the ESE type, or you could just use a basic lightning protection system just using a conventional type. So how we decide and where we use the LPS? So the answer for that is do the risk assessment. So in the risk assessment, of course, risk assessment is a thorough and fair assessment of the facility to identify and gauge the level of potential lightning strike that may occur. Then, this assessment will be a reference to guide on a measure should be in place to eliminate the risk. So, in every risk assessment, even a risk assessment for an arc flash or an electrical system, or in a workplace station industrial. So the main reason we do the risk assessment is to eliminate the risk. So for a lightning protection system, so basically I have here a sample of a risk assessment I made on some of my project in a this project is on a mountainous area. So for a risk assessment, basically it will be needing the parameters. So parameters for dimensions of the structures, so characteristics of the structures, and the environmental influence. So with that, you could provide a risk assessment. So the discussions of a risk assessment would be separated for a lightning protection system. So I created a separate video to discuss this risk assessment. So let's go now on another chapter of these presentations, which is the design. So for the design, so I divided it on 3 parts. So first part is the protection coverage layout. So the mounting, second is the mounting structure, and the grounding system. So that's the lightning protection system design consists of. So for the protection coverage, so this is where we define the protection radius depending on the air terminal and its corresponding risk strike. So for protection coverage, so if you notice, they have a radius defined there and the protection level written on the layout. So here, this part. So I'm gonna use yellow, this part and this part. So with this data, you could get it on your risk assessment, the previous one, before going through the design. So you do first the risk assessment, then if it need a lighting protection system, your facilities need a lighting protection system, then do the lighting protection system design. So for the design, so for the protection coverage layout, you could get this data on your air terminal specifications based on your manufacturers or your prepared brand. So for here, I use the EEngineering brand as mostly of my projects. So EEngineering brand I'm using on this. So that's why I adapted these specifications they are using. So it's not standardized in terms of this defined in the electrical code. This data is you can get it on your manufacturer. So second is the mounting structure. So for the mounting structure layout, so this will basically detail of the plan on how will the design will be hold the air terminal. So this is the air terminal part. So and the mounting to the building extending to the roof. So that's the mounting structure. So basically focus on the extending your lightning air terminal and mounted on your top at the highest point. So next one is the grounding system. If you are electrical practitioner, so definitely this discussion for grounding is just a small discussion. So grounding system, which include the down conductor. So down conductor, you can find it the connection to the mast, the lightning arrestor, then the mast, then going down to the ground and then connected at this point. So that's our grounding system for the design of the LPS system. For the protection coverage, so these are the things to consider in doing the LPS protection coverage design. So first consideration I write here is the using the area of the building to be protected. Of course, we need the area of the building. That's why if you notice in the risk assessment, it is already considered the length, the height, and the width of the area to be protected, or just to for exact word is the structure of the building. You need that data, so because you want it to protect. So protection coverage, from the name itself or the layout itself, you could know that this is for the protection coverage, or where it would be protected. Of if it is one building, so actually I have your sample, so maybe I could later discuss it. So the next one is the height of the facility. So this is because of a approach or a logical approach with this is if you have a high elevation, they have a much higher risk of lightning strike compared to a low elevation like residential house in the space. So that's the main reasons for a protection coverage. Second thing to consider is for a large facility here. So for a large facility location, so to be protected in installation. So like here, it's mostly this is a design of a condominium compound. So these are already existed building. I think I will be discussing it on my sample. So this is all already existing, and this is a proposal, so still ongoing and maybe in still for future expansions of the facilities, this facility. So due to a due to a large terminal protection coverage, so which manufacturer given us a wide variety of lightning protection radius, so LPS now can cover a large area. That's why strategically position the LPS for efficient and effective protection to give the facility some safeguard to the engineers or the designer and to the occupant, and save money in the in building the lightning protection system to the facility. So you will see how I designed this facilities. Okay, so let's go now on the next page. Protection coverage. So let's go for a type of facility. So I define here the type of a facility and its case. So for a type of a facility, it is a condominium compound. So one building is already constructed here, this one, but not occupied. Actually, I think it's not occupied at that time we are building it, but now it is already occupied. So future building to be constructed here, this is future building. Then recreational facility is already existed, like basketball court here, this basketball court, swimming pool, so at this part. Then there are some recreational facility here, and the clubhouse or the admin building. So with that, as you can see, I use a 113 meter radius protections or air terminal with a radius protection of that much. So all the facilities are almost 90%, maybe I could say it 90, because this part is only not under its protection radius, so maybe 90%, I could say it's 90%. It already covered for the lightning strike. So basically, even it is for future, so you already covered the whole facility. That's why it is important to study the facilities, not in a just a structure itself for a building only, but if it is facility, a large facility, just consider studying how, so that you strategically position your air terminal to cover all the facilities. Okay, sample number 2. I have here for sample number 2, another condominium compound. So for our case here, the building facility is constructed horizontally and parallel to each other. One building is already constructed and occupied by a condo owner. The compound have ongoing and future building to be constructed. Okay, so this facility at that time is already done and already occupied. So there already have owner of this condominium, so the tenant, and then this building is still ongoing at that time we are doing the installation, but the recreational facilities like basketball court and the admin buildings or in the clubhouse are already existed. This building is ongoing at that time. So at that time, so we have a problem if we install the lightning protection at this building. Number one consideration, that is the construction phase. So since it's already occupied, we have a limited on doing a job to install the lightning protection system. That's why we decided to install it at a building under construction. So within that said, so we found out that it still covered the almost part of the facilities that already occupied. Number one, the building which is already occupied, and the future two buildings. This one, future two buildings. It is an open area at that time. And then I already covered the admin building or the clubhouse and the basketball court. So and then the ongoing construction at the same pace of this. So for their future, since this building is not occupied, not occupied, not occupied, not occupied, and still not there, the only have is the guardhouse. So with that, I already have made a strategic design so that lighting protection system could be lessen their cost. That's why it is important to consider your vicinity, or what do you call that? Sorry, not vicinity, a development plan. So just review first the development plan if you have it, to picture out how you strategically position the lighting protection system. Okay, for the sample number 3, so it is a big project, yes. So a solar farm or a power plant. So for our case, okay, where's my cursor? In here. For our case, I have a 160-hectare land area to be protected for lightning strike. An open area in a mountain. So some areas have forests and high trees that are not allowed to cut down, so just an owner decision to have it not cut down. Then and also a government rulings for that tree because it's too old. So and another is to protect and cover the solar panel, so that's the main goal here, and the rectifying transformer. Before this, for protection lighting, before we go here just to design and provide a lighting protection system and install a lighting protection system, there's an incident that lighting strike their panel and they have a massive loss of solar panel. That's why they decided to have installed a lightning protection system. So for our lightning protection system, number one here is the solar panel itself to cover it and protected it, and the rectifier transformer. So you may notice this part, that is the rectifying this space, rectangular space, that is a location usually of the rectifying transformer. So if you notice, so I want it to protect this part. That's why most of the earth terminal location, the lighting at the LPS locations, is near to the rectifier transformers, since it have a high radius, large radius protection of the LPS. So I could cover the solar panel while still protecting primarily the rectifying transformer, which covered. Okay, this is their, I think this is their substations, a 13.8 kV if I'm not mistaken. Okay, and then so I have another sample for number 4, a so type of facility, institutional facility. Case facility have farm sorry, fish pond, 23 open basketball court and tennis court. So swimming pool. Tall building is 7-story. So there is an existing LPS radius with low radius protection, so it's much smaller. Maybe we use smaller radius protection as compared to the one we are using, and the defective air terminal. Okay, so the blue one, I have here noticed the proposed design of LPS. So the red one is the existing one with 80-meter radius protection. Then the green one is, they just said that it is defective one. So we did not do a testing, but the owner and the engineering maintenance said that the device is already defective. So this brand, I don't know if it is, if I'm not mistaken, this is a brand. I don't think I need to mention the brand, so because I have story of it. So number one is the other one is the relocation one. So if you notice, so these are our plan to for our protection, but in the progress of the work they decided to change it, the existing one, to a 100, I think 108 meter radius protection, same as my yes, that is an 108-meter protection radius lighting arrestor. This is an open area freestanding design. This design is on the installed in the roof. This design, this existing building with defect marked as defective is installed on the building. Then this is a freestanding design, this green one, and here is a freestanding design, an existing one. So our proposal is to have additional 4 while still operating the existing one, but they decided to install another lightning protections, to change the 80-meter one to have a greater radius protections, and additional somewhere here another 108 to cover most of, sorry for my drawing, I don't have right now the pen. So I will tell you the story why this happened. So do you think the design is over design, or they just want to protect? So actually the reason for that is this building, sorry, not building, this facility have a twin facility, almost the same. So the facility have this, the one we already installed, this project is a boys town, and the one that I'm saying is a twin facility is a girls town. So there is a instance, or there is a event that in their design, so you may refer, I think I could I clear the drawing I made? Yes, I could clear. So you just base the design on the color green one. So the color green one, which marked as defective, which is typical to another facility that I'm saying. So the problem arise there is a girl hit by a lightning strike. So if you will notice, the open area for them is this, that is a basketball court or the open field. So at that time there is a cloud, then darky cloudy, and then the young girl struck by a lightning. So that's why the owner investigates, so why girl is like struck by a lightning, but we have a lightning protection. So upon investigations and doing the investigations for that, so that's in tragic event, the protection radius this brand is, they treat this as a defective one since it's not protected the girl which is struck by a lightning. With that incident, they decided to have a protection radius to completely cover the facilities with the lightning protection system. That's why we already have here. So if you will notice, we have one, let's say this is one in our design for our this facility, 2, then 3, then 4, then this is already adjusted, so that's 108 also, that's 5, and another here to cover, so that's 6 with a 106 lightning protection radius for that. That's the incident happened on this. That's why it come up with too much umbrella or overlapping design. I also just to also mention, so the best design for lighting protection system, like in a larger facility like this, so an overlapping of protection radius. Yeah, that's the best practice, or if you are a designer, so that's the best practice to do in designing lighting protection system, the overlapping lighting protection system. In terms of protection radius, okay, so I have here a sample number 5. So industrial facilities, so in this case, so manufacturing facilities with a multiple buildings separated by the public roads. That the problem in this, it is a manufacturing a paper towel, tissues, and napkins. Mhm. So here is the public road standing at this portion. That's the main problem for lightning protection. That's why we have two lightning protection here, and your neighboring facilities have already protections because of you. And there is a residential houses at this portion. So you already also protect your neighbor residential houses. Okay, let's now on the second part of the design, which is the LPS mounting structure layout. So after defining the location in the protection coverage layout, securing the LPS pole is visible in the location selected. So we will go now for this, the design of the lightning pole and support and mounting details, which is under our mounting structure layout. So basically for our lighting structure layout, so this layout plan may require civil engineer for a design of the lighting protection structures or the mounting structures. So depending on the case, so that's a case-to-case basis. So this layout are for basically depending on the requirements of the air terminal. Again, that's what I'm saying before, that you need to have a referral, what they call this, manufacturers of what air terminal you are using. So basically the one I'm using before this brand is the Helita. I don't know if you know that, the Helita. Then I go now on Ingesco brand. So this is not a sponsored video, but I am using this lighting protection system for more over a number of projects. So you will see here at the end. So and the second goal of this design for the mounting structure is to provide an access for a maintenance afterward. So the third reason for this design also is to position firmly the LPS, since it is exposed on the outside environment and extreme weather condition, which is it is installed at the highest point or at the top of our facilities. So I have the sample case or case basis for a year. So I have here a designs. First design sample is the mounting locations. I define here the mounting location. So top of the roof parapet wall. So you could get the details. So I could share the details drawing for it so that you could use. So top roof parapet wall. So the mounting structure is, I think it is like this, like that. So this is the parapet wall of the roof of the facilities, and this is the roof line. That's how we mount this. So this is a front, this is a side, here I stated left side view. Okay, here like this. So this is our front views and the side view elevation. So now, and the second sample is installed at the roof ridge. So for a roof ridge, you need to have the size of this if it is already existing. Validity. Usually in the practice and in my experience, so lighting protection system are not prioritized by the owner. They install the lighting protection system afterward. So that's my base experience for it. So this is how I design. Usually this small inner ridge, before I designed, in older design it is just 3-meter high, but now I'm using a 5-meter high lightning fold for my air terminal. Most of it is greater than 5-meter. I'm not using a smaller sizes like this 3-meter. So sample number 3 is the installed in the elevator deck. So that's, since it is the peak one or the highest point of your facility, so that's a strategic locations for the LPS. So basically the design, structure and design, sorry I forgot to discuss it. So number 1 is the air terminal mass installation. So air terminal mass, actually this is the only air terminal mass. Sorry, I forgot to discuss it here. That is the air terminal mass connecting the air terminal. This one is the air terminal, our air terminal. Then if you have a guying, required guying design, so just a eye bolt mounting structures, then a pad or a base plate for our mounting of lightning protection, then the guying support, and of course the footstep for the maintenance purposes and afterwards. So this is how it looked like an installation. So down conductor there and goes down. This is the elevator deck part. Okay, number 4, so a freestanding one to the ground. So almost the same here. It does happen. The difference with it is the foundations or a column for to support or hold the lighting pole. So mostly freestanding design have high elevation height, like here that is 6 plus 6 12 plus 4 12, so that is 16. That is 16, almost 16.5 meter high, mostly freestanding because we want it to extend at the and this would be the top at among the area. That's why freestanding is much higher in terms of elevations. And lastly for our design is the grounding layout system. So basically for our grounding system, if you are practicing electrical, so you know this electrical grounding layout, so you will be needing to provide a grounding layout plan, the grounding pit or the well manhole details, the grounding installation detail. So some other are using a manhole of a already prefabricated, but I'm not using that. Some are too weak. Okay. And the grounding installation details. So let's go for details. So for the details, wait, where's my cursor? Where is so for our grounding system layout, the grounding connection details. So for this, so this is our lightning strike counter from down conductor air. This part is from air terminal going down the down conductor, then flow onto the lightning strike counter, then going to our first grounding well or ground pit, which is called as a test pit. So we test pit, so we do have here a point of disconnecting the down conductor and the what do you call it, the grounding system. Okay, I will present first the grounding system before I explain the test pit. So for the grounding connections, I have here three methods. We have three methods, or there might be another, but this is the common grounding system. So grounding system method. So for first method is just a straight line lightning grounding system. Then a method number 2 is a triad, and then the triad design and the grid grounding. So what I prepared here is most of my project installations is I use the triad, this one, the triad design. So the main reason that I prefer triad, if there is a problem, let's say the ground wire cut down, so ground number 1 still connected, 1 2 3, if there become a problem at this point, so still ground rod are still interconnected, unlike with number 1, if there's problem here, so it reduces your ground rod, so of course it would reduce your ground resistance. So that's my main reason. But for grid grounding, yes, it's still connected, almost the same as a triad design. So if there's cut, it's still connected with each other. can connect to each other and still can connect to each other. So that's advantage of a grid, grounding, and triad. But basically or mostly I use a triad design for my lightning protection system. So I think triad design is enough for our lightning protection system. So of course, if it's not enough, so you may be needing another ground rod to be buried just to compensate or just to have the required grounding resistance for it. Okay, and also by the way, the one I'm saying, this first part is always our test pit. So or the for our test. So why it is test pit? So this is the common what do you call it, a problem neglected by a contractor or other contractor, that the design for the lighting protections must have a ground test. So what's the reason then? If afterward you already after your turnovering, so you will be maintaining the facility, the owner or the building engineers will be maintaining the facilities, so you need to isolate this from the air terminals. Can I go back to the slide? No, I think I cannot. So if you notice, this is from the I have drawing it, so sorry for my drawing. So if this is the grounding connection, the down conductor then will tap to our first. So this is from our air terminal. So if you do a maintenance or doing a testing, so how will you test the grounding resistance? So if you test here, it also include your air terminal. That's why other air terminal, before it turns over, because we do a testing before we turn over it to owner, other air terminal been damaged because of the voltage injected here. So our ground air testing, if they injected a voltage, specifically the fall point method, right? The fall point method. And if it is ground clamp, I don't know if they have already studied it, but I think it could not affect. But if you do a false point testing, so of course you ejected it, and also included your down conductor in your test. That's why for me, or in practice, you should have an isolation. So that's why we have a direct burr or clamp one, so that you could isolate and do the testing of the ground rod alone, not including the air terminal, or you will not be feeding a voltage and current in your air terminal, even it is a small radius. Of course, it would not be covered by your manufacturers if you damage the air terminal at the first place. So that's the main reason we have a test pit to isolate. Also, number one is to isolate our down conductor and air terminal to test the grounding system. Okay, so this is the sampled output of the design. So basically we have the technical specifications, so the general air terminal details or requirements for your air terminals, then air terminal supports, which is the mounting structure, the part 2 of our part 2. These are part 1 of our projects. Then this is the part 2 also of the design, so the protection coverage. This number 1 is this is the protection coverage. This number 2 is the air terminal, and terminal support is for the mounting structures. The down conductor and the earthing is for our grounding, which is already defined. Then you should have the details, the protection, the layout, of course, the location. That is important, because location, if you do the risk assessment, you need a location so that you know the lightning strike per day and per year. So you will be needing it to do a risk assessment. So that's why you need a location map, a specific location. And so the elevations and the mounting details, so I included it on the sheet number 3. Number 2, sorry. And then the LPS pole details. That's it. You have three basic sheet, so if there is might be an additional sheet, so it could be, but basically these 3 sheets could provide now as our LPS design. So for another one is which is the installation. So for our installation, so I prepared or I list a material for common materials that you will be needing in order to have a lighting protection system. And by the way, again, I just reminding you that we are talking about ESE type. So if it is conventional or other type of lighting protection system, so maybe we will be eliminating some of the item here. But we are talking about here the ESE type. So for an ESE type, so you will be needing the air terminal. So this is it, this portion, that is the air terminal, the mass, which is mounting of the one who will hold the air terminal, and the down conductor, that's the purpose of our mass, and the lightning strike counter. So these 3 items, basically you could buy it on set. If you buy air terminal, it already included the air terminal mass and lightning strike counter. Of course, it is a design or based on the manufacturer. So the LPS pole, the lightning protection system pole here, it is fabricated. Then a direct burial clamp. This is used for my test bed. That's why it is only one. So that's my for a test pit. So the one will from down conductor going through the first ground pit, the ground earth pit. So second is the guying. So for guying, if it needed your design to be have a guying, but other may not be required this guying. A copper ground rod, yes, it is important. So this is a minimum size. You could go larger on it. Then a concrete ground pit well. So again, that's why I'm saying in more dry fit, I do not buy ground pit. I construct my ground well pit. So machine bolts, then a 60 mm bare copper wire. So used as a down conductor and the grounding. So actually the code give us the minimum size for a lighting protection system, if I'm not mistaken, that is 50 mm squared. So but I'm using a much higher on the minimum requirements for a lighting protection system for down conductor, but you could use a 50 mm squared bare copper wire or other type, you could use also that. Then the exothermic material for our grounding system and bonding of the ground rod and the cable. Okay. So for the installations process, so this is simple. LPS pole fabrications of the material, that's the step 1. Of course, you will be needing first your material before you do the installations. Then constructions of concrete structures and the excavations of the grounding fit, like in the image. Then installations or standing of your lightning protection pole, the installations and fitting of air terminal down conductor and the strike counter. Then air terminal burying and exothermic welding of the grounding system. So for exothermic welding, so I have here another videos, so you can check it or on a above link on how to use exothermic welding. So we have the discussion on it. So here another case-to-case basis for a sample. So with your design, so actually most presented in case basis for our design, this already been materialized, and we are the one who do the executions and installations of the project. So for the first one in the solar power farm, so a freestanding design, installation sample. Another sample is the industrial, so an ice cream plant. So before discussing this, so I have some additional informations to you if you are installing or designing a lighting protection system. So if you will notice that there is a device, I think it is a anemometer from the facilities is not connected to our lighting protection system. There's nothing doing with our lighting protection system. So there is a project before we go on a condominium design of lighting protection system. So they using a air terminal. So air terminal, I cannot say the brand, but the problem happen is there is a lightning strike happen on the facilities, and of course we have lighting protection system because we want that lightning leader, we call this as step leader. The lightning to be strike to the ground should be strike at our lightning arrestor and flow onto our grounding system. So the problem happen is that the step leader, the lightning strike, did not strike our lightning facilities but strike the structure. The structure hit by the lightning is near almost around 250, almost 200 mm, 200 from our lightning air terminal. So the lightning strike at the structure, so which damaged the concrete structure. That's why here, actually this project is a preventive maintenance of the electrical system of them, but also an electrical safety audit. So that's why I recommend to remove this and have it transferred to other one, because these distance are too near in my experience, so or in my design. So as an engineer, I'll not allow this kind of design to have near to the lightning protection system, even though the code give us to be it at least minimum of 250 mm distance. I think it's 250 mm distance, the allowable distance for the air terminal. I'm not 100% sure, but you could check, but I think it is range from that. Even though this distance is, the design of this facility is around 500 mm. This is 500 mm, but I still not allow this as a safety precautions because of that incident. So because of the incidents I found in some of the facilities, that air terminal, even though I'm confident with this brand which I already use it with my most of my project, so still I'm not allowing, because that's a additional precautionary measure for you as an engineer, or as you are practicing a much safer facilities. You already protections, and if it is hit, they might be a damage to the properties, because it is an ionometer, there is a cable of it, and there might be a problem. That's why I advise them to remove this. This could be a risk or hazard. That's why I advise them to remove, and it is already been transferred to other location. Just I advise for the one who are starting in the design or the installations. So limit the distance of the, because we want our lighting protections to be at the topmost or the highest elevation, so that it would not be affected the below the air terminal. So we want to protect our system, so we want also to isolate the strike at this portion, so will not be including below this level. That's why I recommend not to do or install like this one. If you will notice some other design for a much higher lightning protection system, the pilot light for the warning sign is installed parallel or along the pipe, along the structure of this, along the structure. That's the good design, not a separated one. That's why I'm not allowing this one. If it is installed in along the pipe, so I think it is best, because it is below and along, which is the lightning protection system are there before it could be strike here. That's my main reason. But again, there is a prevailing code that still allow this, but as a practicing, so I'm not allowing this kind of installations. And a third sample is a condominium mid-rise. So this, but for this project we have a additional. The owner want it to have it guy wire. That's why we installed a additional 4 guy wire for this. Before installation, this antenna is not there, so we just installed the pole clearly without these distractions of the antenna, but it will not be affect the lightning protection system. So still, that's there not be a problem if they already installed the signal for a TB. Then for a sample number 4, so industrial facility, so paper towel and tissues, so installed on the edge of the concrete, top of the you're at the edge. So mostly the designer's edge, if again the one I'm saying to you before, that lighting protection system design are not prioritized in most facilities. They installed it afterward. That's why installations of lighting protection system are mostly installed on the edge, because of they don't have provisions for a down conductor. That's why it make easy for us to have the down conductor at the edge, so that we could install a down conductor at this portion, like that, straight path, because we want a lighting protection system without a bend or loop. We want it straight down to the ground. That's a best practice for the design of the lighting protection system. Sample number 4 is the open field. So I think this is almost 12 or 13 meter high for an open field design. This is a freestanding, I think 15 meter high lighting protection pole. Sample number 5 is in the institutional Aboy's Town, so with installed on the top roof. I think it is a 5-story building, and the another 3 meter high of lighting protection system. The structure is 5 meter high. The structure we installed the LPS. Then sample number 6 is an agri farm. So this is a 20 meter high lighting pole for a agri farm. And finally, for our testing and commissioning, so this would be a short discussions of the essential testing for the LPS. So I have only 3 testing for the LPS. So number 1, of course, the ground earth resistance, the continuity test, the lightning arrestor test. So for the test, so this test will determine the resistance between the ground rod electrode and the earth to make sure it can withstand the lightning strike. So that's the main reason. So we want to, that's why we arrest the lightning arrestor. Actually, I am favor that we are not arresting the lightning. We are just giving a way, in much easier way to, or a safer way, that the lightning can discharge, so that it would not be hit by structures, facilities, or human beings. So we are not arresting it. We are just giving a path or extension so that they will be flowing at that. So we're just giving it highway. So I think the arrestor is not the right term to use, but of course that's a professional. I don't know if other professional will agree with me, but I think that's, we are just giving a way on where our down or grounding are the lightning strike go. We are just giving a highway for it. Okay, that's the grounding. So you could do a like this, so clamp type testing of grounding, and then a fall point, and there's other lightning protection system, so you could use that So that's the primary test. So you need to be at least less than 5 ohms. So that's the maximum value you could go. So that's the as per code. But in my experience in doing a lightning protection using a triad design, that's why I preferred a triad lightning that's a triad grounding system. So I preferred that because I get much smaller values there. So I get 0.5 like in the image, 0.5, 0.8, which is lesser from the allowable, so which is 5 ohm. So that's why I recommend triad for the lightning protection system. Maybe the soil quality here in the Philippines is a main reason for it. But if that, you could do your soil resistivity test before going on the design of your grounding in your country. So is the continuity test. Actually, this is simple testing. So of course, if you buy a new cable or down conductor, there is a continuity of it. But for a safer or a as per record for given to the owner, we do a continuity test report. So we do continuity test just to make sure that there is a continuity, specifically the one designed with a longer from top to the tapping grounding system. So you need to do a continuity test. So that's the another reason. Specifically, if the device, if it is new, yes, we still do a continuity test as a formality. But as practicing, we all know that if it is new, then they have a concrete definite continuity. But for a existing one, so maybe you should do a continuity test. The reason is maybe there might be a cut down due to the lightning strike, which cable cannot withstand, and then is a cut on the middle or fold which you could not be seen. So that's why continuity test may be a essential part of the testing. Simple, using multi-tester, so you could do the not special tester. So you do a continuity test, just a simple test. And the lightning arrestor test. So most of the air terminal manufacturer doesn't have, or doesn't have this kind of testing. So other have. So basically this lighting tester is specific to the brand you are using. So like this, it is a simple testing. So actually they did not define what they are testing. I mean what data they are getting here, this tester, because this tester is intended only for their device, for their equipment, for their terminal. So like here, if you will notice, either it is okay or fail. If you review their site for this detail of this lighting arrestor tester, so they did not define what they are getting here. So they just said that it is okay or failed. So but for a maintenance, for us to have a, maybe the manufacturer don't want some details on their air terminal, so may be copied by other manufacturers. But yes, it is important to have a tester given by the manufacturers, so that the owners or the owner of the facilities have a, what I call that, a security that the air terminal is still functioning, so which is can get by the certified. But I have some compensations if you are using a air lightning arrestor or the air terminal which doesn't have a EEngineering lightning tester or the lighting tester. As for your supplier to have like this, a air terminal test report, actually the only testing before the device could be used is the laboratory, since it is a lightning at a higher voltage and it could higher current. So ask them to give you a air terminal test report So with that, you have a certification that your device is functioning, specifically if you are a contractor or a supplier or what they call distributor of for this brand. So as for this kind of certificate like this, it is a at level so electrotechnical testing laboratory. So the device is tested, so I just blank it out the serial numbers and the sign of this. But yes, you could ask for this test so that you have a security for your air terminal, because as my experience in designing and supplying and the constructions of the lighting protection system, so since they are not professional, the almost owner is not professional, the main question there for them is how we know that that device is functioning. Actually, I asked by the definite my client. They asked me how do we even know that if that device is functioning? So that's why I certified it. I give a certifications and warranty certificate. You could also provide it if you are a contractor. Give a warranty certificate and this test if you don't have a device to do the testing. And that's it. I hope you learned something for our discussions for our lighting protection system, so the design, installations, and testing. Thank you. For further discovery engineering life, please like and subscribe to our channel to give you an updates as we electrify our world.